In this video, we will develop the product, power, and quotient rules to simplify exponential expressions. This video is going to be more of an investigation to see where those rules come from, why those rules are even necessary for when we're simplifying exponential expressions. First is the product rule. Remember that word product is really the answer to a multiplication problem. So the product rule is going to have to do with products. Here we have x to the fourth times x cubed. These two things are being multiplied together. So what will our product look like? Well, in order to figure out what to do with these exponents, maybe we could write it in this expanded form. X to the fourth is x times x times x times x. X cubed is x times x times x. Then once we see it in this expanded form, we say, oh, well, we see 7 x's being multiplied by itself. And what could that look like in an exponential form? And our answer is x to the 7th. So instead of writing x to the fourth times x cubed, we could just write it as x to the 7th when it's simplified. What about x to the 5th times x to the 8th? When we write it out in that expanded form, we have x times x times x times x times x for x to the 5th, and x times x times x 8 times for x to the 8th. And we're multiplying those together. Well, in all, how many times are we multiplying x by itself? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's x to the 13th when it's simplified. But as you can see, as those powers start to get larger and larger, it becomes really cumbersome to have to write out x times x times x that many times. So it's really going to be helpful if we can notice a pattern in what we're doing here with those exponents. So maybe let's look at the next one, x cubed times x squared. Well, if I write that out, I have x times x times x times x times x, and we can see that that's really x to the 5th. So hopefully you guys are noticing a pattern here. What are we doing with those expressions to simplify them? What's happening from x to the 4th times x cubed to get x to the 7th? X to the 5th times x to the 8th gives me x to the 13th. What do you notice is happening every time? Look at the pattern. So when we formulate that rule, what's happening with those exponents? So we can see that we're really just adding those exponents together. 4 plus 3 is 7. 5 plus 8 is 13. 3 plus 2 is 5. All right, I want you guys to describe the pattern that we saw for the product rule. Next is going to be the quotient rule. Remember, the quotient is an answer to a division problem. So we see in our original expression here, we have x to the 5th divided by x cubed. So we have a division problem, and we have to figure out what that quotient is. So once again, we're going to use that expanded form to help us simplify first. So we see x to the 5th on top, so we have all of these x's to represent x to the 5th. Then x to the 3rd power on the bottom. Now I want to remember here, we kind of have some things we can simplify. X over itself, or anything over itself, is really just 1. So we have some terms here that can actually reduce away. So we have x over x that reduces out to 1. X over x here that reduces out to 1. And then x over x again. Now I don't have any more x's on the bottom here to be able to reduce out any more, so I just have to look at what's left. I have x times x left, which is really just x squared. Okay, as we do more and more of these, look for that pattern. Look at how we could have looked at that original expression and jumped to that answer. Because x to the 7th over x cubed, remember, it starts to get really cumbersome to have to write that over and over. Well, what's that going to look like when we can reduce out? I can reduce out one pair, another pair, and one more pair. So how many x's do we have left being multiplied by themselves? 1, 2, 3, and 4. So our answer is x to the 4th. Okay, next, notice here we have x to the 5th divided by x to the 8th. So what happens here? Well, we can start to cancel out our pairs. I have one pair here that reduces away, one pair here that reduces, another, and one more. Notice this time that I'm left with x's in the denominator. So I can't move them just to the numerator. I have to leave them where they are. But what's left in the numerator? There really is a 1 left. That's what these x's are reducing to. It's really a 1 left on top. Or 1 over x times x times x. And what does that look like? That would be 1 over x cubed. Now, what's the pattern here? What's happening each time? So as we look at 5 and 3, how could we use that 5 and 3 to get a 2? How could we use a 7 and a 3 to get a 4? So if you notice, we're actually subtracting those exponents. So the numerator minus the denominator's exponent. So x to the 5th over x cubed, 5 minus 3 gives me x squared. X to the 7th over x cubed, 7 minus 3 gives me x to the 4th. What about this other example? What's happening here? I have 5 minus 8. Well, that's really x to the negative 3. And we'll do more with negative exponents next time. But I want you to know here that these are really equivalent. 1 over x cubed and x to the negative 3 are really the same. Once again, I want you guys to include in your notes how you describe the pattern for the quotient rule. Next is the power rule. So power means exponent. So here we're actually raising that expression to an exponent. So as you notice here in this expression, I have x squared raised to a power. We also call this power to a power rule. So I have a power raised to a power. So what does that look like? X squared cubed. I have x squared times x squared times x squared. X squared multiplied by itself 3 times. If I expanded that even further, I have x times x times x times x times x times x. How many x's are being multiplied by themselves? It's x to the 6th. Okay, let's look at x to the 5th cubed. So x to the 5th cubed is x to the 5th times x to the 5th times x to the 5th. Well, what if we expanded that even more? What would that look like? Well, we would have x times x times x times x times x, times x times x times x, all the way until we have all of those expanded. Now, how many x's are being multiplied? Well, I have 5 here, and then 5 more, and then 5 more again. So I have x to the 15th when I simplify that. Notice how long it took us to do that if we had to do expanded form every time. So let's anticipate what we would do with this x cubed to the 4th. So x cubed to the 4th would look like x cubed times x cubed times x cubed times x cubed. If we were to expand that, what would that look like? So we'd have x times x times x times x times x times x, all the way until the end, until we're done expanding it. So how many x's are being multiplied total? Well, it's x to the 12th. So what's the pattern here? What are we doing with those exponents? How do you use a 2 and a 3 to get a 6? Or a 5 and a 3 to get a 15? Or a 3 and a 4 to get a 12? So if we have any set of exponents a and b, what's happening there? We can see that we're really multiplying those exponents. So go ahead and describe the pattern that we saw for the power rule. Lastly, I really want to focus on the summary for this lesson. Summarize and describe the product, power, and quotient rules based on the observed patterns. So I really want you to write about what the rules do. And then I want you to answer the last question. How are the power rule and product rule different? Really dive into that question and look at maybe what you're given. How is what you're given different so that you know what to do with the exponents?